I'm going to talk about assertions. I see somebody already trying to kick the tires. This is a feature to be. This is not yet a feature. Just one of that. So I'm a Postgres contributor, a fairly minor one. I do some AntiSchool, and occasionally I manage the commit fests. Anybody familiar with those? Okay, that's more than I expected. If anybody would like to participate in the current commit fest by reviewing patches, stuff like that, the resource that we're shortest on in commit fest is people's eyes looking at code. Well, I guess that intro is not one for the ages. So that's what I do. What are assertions? So data constraints. Expressed in SQL, which is kind of important to the process, which can span multiple tables in ways we haven't been able to do it before. Woo! And here's an example from an older implementation. We've got a tool lending library. The tools are fungible. If you have a flock of ball peen hammers, they're all interchangeable. We don't track them individually. So that's a thing that's a little bit different from how you normally think of in database management. You usually want a unique identifier on each one, but it's not necessary to do that, and in this application it doesn't matter. You just want to know that you want to know how many you have on hand and how many are out and who has them. But not necessarily which ones. So can everybody read this from back there?
Yeah.
Okay, cool. So available tool, give it a auto-generated ID just because it's a little simpler to do it that way than natural keys. Anybody really religiously use natural keys? Thanks. So there's some constraints on there. They describe the tool that you've got and how many are in the inventory. And we make sure that available is non-negative. If anybody knows how to make available negative, please let me know. I want to know about the physics of how this would work. Okay. Now, to track the tools that are checked out, we have a table that just says which tool ID we're referring to, so the one corresponding to ball peen hammer, for example. And checked out by as a text, which is my way of saying there's a natural key to the tool users table. Okay, so what should happen when somebody checks out tools? Well, we want to establish that that the tools were that the tools in the inventory correspond to checkouts, and that there's never more checkouts than there are tools, because that reflects the physics of the situation. So what are we going to say here? We make an assertion, and it says check, and then let's look at what happens here. Okay, so reading from the innermost select there, starting here. So what does this what does this query do? Anybody? Sorry?
Counts how many of a certain type of tool are already checked out.
Okay, so let me walk through it. We joined the available tools to the checked out tools, so that we can, make sure we're talking about the same tools. And then we count then we group by tool ID in the available tools. And so the aggregate, the count star that you get there, that's how many entries there are in the checked out tools table. Okay. So that's, okay, so that count is the count, and we're comparing that to how many were available in the inventory in the first place. So what we're saying here about the whole state of the database, and that's what I like about SQL, is you're declaring something. You're not like saying how it's done. You're just saying, this is the effect I want to have. Well, the effect I want to have is that there does not exist a situation where this query returns something. Does that make sense so far, or do we want to? Yes?
Is it a Boolean essentially, or is it more complicated?
The question was, is it a Boolean essentially, or is it more complicated? And the answer is the assertion has to produce a Boolean result, and I'm not exactly sure what the standard says about a null one. But I strongly suggest that you not arrange things in your assertion creation stuff that could come up null. Okay, so we create this assertion. It's not on anything, although it looks like it looks superficially a little like a check constraint on a table. But instead we're saying we want this query never to return a row. So count star greater than available, that means you've checked out 6 ball peen hammers and there's only actually 5. So we want to just say, if somebody ever tries to make this happen, we want to raise a hand or a middle finger or something and say no. I was going to do a live demo. Unfortunately, my laptop crashed on the way over here, so I'm not. So basically, there was a version where that aggregate would actually work in there, where it says having count star. I'll talk about what happened with that code in a little bit, but basically. It didn't quite work at that stage, and now I'm going to show you what you can do if you don't already have assertions in your code, which is, I think that's all but 3 of us on the planet, maybe 2. So we're.
Okay, I got a question, because I'm still a little confused about that assertion sequel that you have there.
Sure.
So the having part.
Oh, okay.
Having count greater than 8 out available. Okay, so when does this rule really apply? Like, let's say that there's 5 tools, 5 are already checked out. Now we're going to go do another one.
Mm-hmm.
Okay, so this having count greater than 5 only happen if we're trying to check out 6.
Right.
But 8 out of 12 is only 5. So this hasn't really happened yet. Right? We're trying to prevent the 6th one from being taken.
Right. So you can think of it as being a little bit like a trigger that fires on writes. Writes only because reads don't change the truth of one of these, and so we don't attempt to check it then.
If we were trying to do another checkout, so for a certain tool, that would be added to the tools checked out table. And if we tried to do that would fail because this assertion would fail.
That,
We probably go to 6.
right, so the not exists would be false because it would exist,
Right.
and it would roll back it would fail, and you'd have to roll back the transaction. Yes?
When does this actually run?
When does it actually run?
Statement time or?
It's at statement time. As far as I know, there is not as far as I know, there's not a deferrable version, but again, my reading of the SQL standard is a little compromised by the fact that it's the SQL standard. Has anybody ever tried to read that thing? Okay, could you explain to me why I'm having trouble figuring out whether per statement?
It's verbose.
It's verbose, yes. I would say it's sort of like somebody tried to riff on eBNF and humanize it or something, but didn't quite manage it. That's what the standard looks like. It's vaguely English-like, but it's yeah. Anyway, so I don't know of a way to do deferrable assertions, if that was your question.
No, I'm just trying to understand the feature. So this would be more or less a statement level further.
Yeah.
In terms of where it executes.
Yeah, it executes basically on a statement. So let's see. If you try to do a single statement that violates this in a transaction, it will of course fail. But I think you can get to many statements. You can do many statements in a transaction unless you've gone and violated it with the effect of the statement you're about to execute. You should be good. Yes?
So I think I'm using the wrong parlance, really more like one of the other sequels, but what happens with views when something like this occurs? Because to the best of my knowledge, this is essentially a check constraint that binds to the schema, 2 tables versus 1. What happens with the view that's sitting on top of a check constraint like this when it runs?
The question is, what happens to a view that sits atop of a schema that has assertions in it?
Versus just check constraints or both, I guess?
I'm not sure I understand what that would have to do with it. This basically, the assertion talks about when you're doing a write, are you changing the state of the database in such a way as to make one of these things be false? So there's these assertions kind of conceptually floating around, monitoring all the write traffic that comes through. And if a piece of write traffic would cause this condition to be violated, then it fails whether it came in through a view or a data pushing function or you name it. Does that get to what you were asking about, or did I miss it?
I think I just need to do a little research on how inserting to views works in PostgreSQL.
Okay, so we'll get to some of the implementation details in a little bit. Yes?
Does it run after each query within a transaction, or does it run at the end of the transaction?
The question was, does it run after each query in the transaction or at the end of the transaction? And I think it's conceptually before each query. So it says, what would have happened here if I ran this?
And think about a transaction, for example, where we try to check something out, and that would, like, there's 5 ball peen hammers out right now. This would add a 6th. But then later on in the query, I say, actually, we've got 10 ball peen hammers right now, and it would be fine if we got to the end of the transaction, but
As
can it
far
fail
as,
before we get there or not?
as far as I know, it fails immediately per statement. So if you want to stick more ball peen hammers in the inventory, you need to do it before in the transaction rather than after. It wouldn't surprise me if there were a thing in the standard that allowed for both behaviors, but the ones that have been implemented so far, they operate on a per statement basis. Yeah. So it's not in Postgres 11. That's a bummer. Let's see here. Where did I put that? Let me take a look at the. Oops. It's not that. It's my speaker deck. Sorry. So it's not going to be elegant or easy to get this right, but we can actually get this effect that I was talking about using some other stuff. So how do we do this? We don't have create assertion. We wanted to write just this elegant piece of declaration and be done, but we can't yet. So we have to write a trigger with its own function for each table, for each assertion. Right? I guess you could roll them up together, but let's get going. So this is what it'll look like now. First, let's see here. Everybody read that one okay? So we're going to make a trigger function. Is everybody familiar with how Postgres does trigger functions separate from the trigger? Okay, so basically in some other systems, trigger functions are not really a thing because you say create trigger and then you write code. In Postgres, you create a function which returns trigger, and then you create triggers off of the function. I know that can be a little confusing. I think the idea was that you should be able to write a function that does many different triggers, depending on where it's at. So they wanted to decouple those things. Okay, so first we do this sort of familiar looking query. At least I hope it looks a little familiar. So we're saying, do we select into this tool variable the type from available tool, having count star greater than a.available. So we're saying at the beginning, when this trigger fires, we ask whether it has already violated. So this is an after trigger. Why is it an after trigger? Anybody?
Well, if you want the same behavior as the assertion code you showed before, then you have to let them actually do the bad thing that is checking out too many in order for the interest to be ready.
Yep. In case the mic didn't pick it up, you have to actually let it try to do the bad thing before it can violate the assertion. So the trigger has to fire after the code has been executed. Okay, so if found, that's basically PLPGSQLEs for the query returned at least a row. then raise this error using error code integrity constraint violation, because I want to call it that. You can use whatever one you want. And a little hint, consider getting more. Okay, so that's one trigger. And then we create the trigger using this trigger function on after insert or update on available tool. Why would I not include the other rights to the, so we could do like insert, update, delete, truncate. Why is it not on those?
Well, delete isn't going to add to the number of tools checked out.
Ding, ding, ding. Delete is not going to add to the number of checked out tools, no matter what you do. At least not on available tool. So there's another trigger function. Now, this one, so we went from, we were in available tools, and we started looking at the other side to aggregate the checked out tools. So the first trigger was on available tools. We reach out to checked out tools, and we see whether we violated the constraint. This one goes the other direction. You have checked out tools, and when you do a write on there, you have to look back to available tools to make sure you're not violating the constraint in that direction. So, again, I kind of compressed the SQL, but it's pretty much the same thing, right? Is there a row that violates the constraint that we established? And if so, we already checked out 5 ball peen hammers. Some of those tools need to come back first. Yeah, and that is, so that's going to happen after also. Now that one is also on inserts or updates because neither one could violate the constraint. Let's see here. So how did we get here? Anybody read this paper? Wow! That is the first time that I've seen this happen. I haven't read it yet.
No?
No. Okay, this is by a guy named Edward F. Codd, aka Ted Codd. Came out in 1970. It's the paper that kind of launched relational database management. So that's why they don't say databases. They hadn't really invented the word just yet. So, large shared data banks. Anyhow, so we're not going to start from there. So where this actually started out, as far as I can trace it, is a thing called serializable snapshot isolation. Anybody familiar with the sort of the isolation? Okay, so serializable snapshot isolation was this really interesting innovation that, as far as I know, was in Postgres first. Somebody will correct me, I'm sure, if I'm wrong about that. And what it does is it creates a directed graph of write transactions, is my understanding. And if it detects a cycle in this graph, it cuts it, because that's the thing that makes that's the thing that makes for serializability. So serializable basically means that the effect you see is as though all the right transactions had executed in some linear order. The linear order doesn't have to be consistent across different clients, but as long as every client sees a linear order, we call that serializable isolation. So it's as though the transactions had actually been sort of queued up and serialized, but they weren't really. Anyway, so Dan Ports and Kevin Grittner put this thing together, and what the capability that they made there was that now you can have stuff kind of floating around inside the database, at least conceptually, which triggers actions on a constraint. So in this particular case, the constraint is the graph must not have a cycle. But the general capability is there's a constraint floating around. Fairly shortly after that, Peter Eisentraut sent out a patch. Says SQL assertions prototype. So coming up on 6 years ago, well, a little over 5 years ago, let's say. And then years pass. Up pops this person that I've never heard of before on the Postgres mailing list. Apparently he's been interested in this problem for a really long time. His name's Joe. And here it goes. Attached is a work in progress patch for SQL insertion. So it is not near production ready, and boy was it not. I had applied it, and you could get one side of the assertion to trigger. The other side, if you tried to write to the other side of the table, the assertion failed to fire somehow, and that was kind of unfun, and that was what I was going to show you in the live demo about almost worked. So a few months later, that's actually the wrong date on there, because the actual date when he sent this is yesterday, late in the evening our time. He's in England. So what he did with what he did with this new patch was that he totally redid it. I don't think it's based on the trigger system anymore. At least as far as I know, it's not. I haven't had a chance to look at the code later, but I got permission to show it off here if anybody wants to see it. This one basically uses as the base assumption the idea that the database is not already in violation of the constraint. So what it does is kind of do something clever whose details I don't know yet, to figure out whether the delta from where you are to where you asked to go is a thing that would violate the assertion. And apparently that's a little bit easier to have to reason about anyway. It may not be any easier to implement. But that was my understanding. So that's the state of things. I was hoping to get this prototype at least compiling. Unfortunately, I was unable to do that. And I'd like to Oh, this is the, here we go. Please do not shoot. That's the last night one. So that's where we are. What's in the box? Documentation. PG catalog changes the information schema. SQL grammar. Some create, alter, and drop support. And other things that I hadn't had a chance to actually look over yet.
What's his reasoning behind do not share this patch with anyone else? Do you know?
The question was, what's his reasoning behind not sharing the patch? And I think it's pride.
He might have somebody looking over.
I think he wants it in a shape that's ready to submit for the commit fest before, like, I go show it to everybody. But he said it was probably okay for me to show it in here. So,
Yeah.
yes.
So, maybe I came in too late to have heard this part, so stop me. What is the motivation for this?
What is the motivation for this? Okay,
So
so.
what are we getting, what's the advantage over just triggers?
Oh, well,
Because it seems quite redundant to triggers.
okay, so, sorry, let me, this is the thing that implements the assertion. It's one declarative statement. And that's the advantage, is that it's a lot easier to reason about this thing than it is to write all the triggers, hope you got the logic right, and then lather, rinse, repeat, because there's no way to make the next trigger any easier, or the next set of triggers any easier than the previous one.
So this is syntactic sugar.
So this is syntactic sugar. Well, I guess it's syntactic sugar, but it's very, very sweet.
Trigger over check constraint.
Okay, which is also sugar.
But, right, so therefore we should get rid of check constraints.
I'm not arguing that, I'm just asking what their motivation is. The answer
Okay,
is
yeah, so the-
30 years is
so the
pretty
motivate-
fine. I just want to know the answer.
Yeah, so for me, I think that making it possible for people to write less code that's easier to reason about, that's my motivation for being interested in this and for trying to shop this around.
So the only thing these can do is rollback?
Sorry?
So the only action these can have is rollback?
Yeah, or at least roll back to save point, because I think you could,
Okay.
when it says error out, yeah. So this isn't a general action capability, although I guess I wouldn't recommend it, and we should probably prevent it, but you could imagine a thing that called something that did a write inside of this statement. I think that would be a really bad idea. I think that this should probably always be a pure function.
So it's a very pretty footjet.
Sorry?
So it's a prettier footjet.
Yeah, I'm pretty sure by the time it gets committed, it will not be, well, okay, so if you create a function that is not immutable and you call it immutable, Postgres cannot really protect you from lying to it.
Well, I think in this case, if you declare, if it, you like had a writable CTE or something inside of it, it would but when it ended, the transaction enters an error state, and it would roll back what you did. So you've expensively rolled back, made some work invisible effectively.
The statement was if you have a writable thing in there, what you're doing if you fail is an expensive rollback, and that is true if the thing that the thing doesn't go out and create its own transaction and commit it, which it very well might do.
does it run in the transaction? Does it run in?
Okay,
It
so-
runs in the transaction context of the statement that's being of what invoked it, right?
Yes, but if you call a user-defined function that happens to spawn a database connection, do a write and do a
Oh,
commit.
sure. Okay. Yeah, that's wacky. I mean, I'm thinking about something that writes to the local database.
Yeah, you're
Yeah.
for the local rights, that's correct. But I'm
You
thinking
know, it could also do it. It could also fork a shell that does an RMRF of the file system. I mean, whatever.
Fair enough.
I'm more concerned about sort of standard database level operations.
I guess my question here on that topic is, if you call a function, suppose you have a function that just logs all read to a table. That's a fairly common thing to trigger. So when you kind of trigger a rule, so if you access that inside this, it's going to do a local write, and suppose your check is passes, so the whole thing commits. So I guess the thing is that it doesn't seem to me there's any handy way to prohibit it from writing without somehow having the transaction state just prohibit further writing at that point for duration of this. I mean, I guess I just have a bazillion questions about the implementation, and starting with, if this basically is just prettier triggers, then why doesn't it use the trigger mechanism? Because check constraints, for example, do use the triggers, and relational constraints do use triggers.
I may have been wrong about what it actually does. As far as I could tell, the thing it needs to do is be able to do some sort of a lock on a predicate. So there's predicates floating around in there, and whether it uses the trigger mechanism or some different one to do its checking, I don't know.
So this is using the serializable transactions only?
Question was, is it for serializable transactions only? And the answer is, I think for now, yes. But to actually get in, it has to serve all the isolation modes. I have this nasty sneaking suspicion that in isolation levels lower than serializable, that you would have to take some very aggressive locks on like every object that could be written.
Does it actually run that query, or is it?
Yeah, it actually runs.
carefully
Yeah, it actually runs the.
optimizing?
Yeah, it actually runs the query as far as I know. Yes, it's syntactic sugar, but it's very sweet and tasty, and
Seems like it might be very fat.
yes, it might very well be that. But I would like to imagine that, I just generally like to write or make it possible to write declarative code rather than procedural code, just because it's a little bit easier to reason about declarative code, at least for me.
What order do these, if you create multiples, do they get applied in an order, or does it not matter?
The question was about the order, and I think it's alphabetical, kind of like triggers are. Yeah, I don't know. I don't know how you would infer an order in broad generality. Apart from that,
And if you had also triggers on the same tables, would the triggers run before or after these?
that is an excellent question. The question was, if you have triggers on the same tables, do those run before or after the assertions? And we can take a look at the patches and see. But I don't know. Sorry.
Because that would, in sometimes you'll use triggers to make up constraints where, you can't insert an order without a customer, but we're going to create a dummy customer. It's a stupid example, but you know what I mean. And so the trigger will just make things right before you try to commit. So is the trigger going to be able to make things right before this prevents it? Or would this, it makes it kind of a difference to your application.
Right. So If I understand right, the kind of trigger you were describing where it like makes sure that something's true before it happens.
And by fixing it,
that's, yeah, by fixing it. I think that usually happens in before triggers. And this at least conceptually runs in an after.
It can happen in after triggers as long as you fix it, you know, and roll back if it doesn't work. I mean,
Okay, so there are
But that's not as
definitely
useful, right? Because like for the
I'm not
case
saying it's a good design, I'm just saying
But-
it's
but
a question
for the
of does
case
this run
of-
first or not.
I mean, if you want to work around a constraint, got to be in before triggers.
It might not be a constraint, it might be business logic. I mean, this is for business logic, right?
Oh, well, that was a very interesting distinction you created that I am not 100% sure I believe, which is between constraints and business logic. I don't necessarily see those as being separable things.
We have constraint as a specific keyword that does specific referential integrity things.
Yeah, it just means
Value
a constraint
Right.
can't be a constraint.
And we use triggers for kind of more general purposes.
Well, I think it makes them, I mean, I haven't looked at the code. To me, it would make the most sense if assertions ran after before triggers, because that's the state of the tuple that's going to be committed, you know.
Yes.
I
don't think you can.
so,
I don't think you can actually mutate tuples with an after trigger, but somebody.
yeah, but that's the point is
Oh,
that you can make an argument either way as to which one's more valuable. But I think the one that's after the tuple that happens after the before trigger is the one that's actually going to get slammed into the database. So that's the one you want to check, you
Right.
know, as opposed to because
Right.
the trigger could in fact take it from an invalid state to a valid state.
Right.
So
I guess the other question is, this isn't really created on a table.
That's right. This looks a little bit like a check constraint, except that you're saying something about does or does not a query satisfy or does or does not this thing return a boolean or return true?
Sure.
And you can write kind of arbitrary bits of SQL in there, or at least you should be able to when
How is it
when
not
it's
going to
implemented.
run it?
Sorry?
I mean, is it going to be just the tables mentioned in from lists inside this?
I would guess that there has to be some way of figuring out what tables might be affected, because you can imagine writing one of these on a view.
Or on a select from a function?
I don't know that you could do, well, I guess if you select from a function, you're trying to solve the halting problem, right?
Well, that's my point. I'm just trying to understand how does the system know when to invoke this thing?
Sorry, can I take that and just, sorry, you,
I apologize, I don't know all of the isolation levels available for Postgres, but is what you're saying, I mean, I'm not sure I understand this conversation 100%, but essentially are we just debating whether I can do a dirty read on two tables on non-committed information that might be stored in this table before I try to insert data that depends on the values that are in there?
So I guess what we were discussing is at what point is it appropriate for this thing to conceptually have executed, and what should it be able to see? So yes, that's kind of.
So you don't want to ever have a dirty read on this
well,
check? ever, right?
yeah, I don't think it's a dirty read in the sense
Yeah,
that.
nothing's been committed.
Yeah,
So
there's no such thing in Postgres as a dirty read as such. You're right, because things have been changed in your own transaction aren't dirty in the sense that read uncommitted, that isolation level means. So you never can see something that some other transaction did. But so if you modify 5 tables in your current transaction, you'll see the current state of 5 tables in the current transaction. You'll see the state of the tables before, and that's not considered a dirty read in Postgres terminology.
So let's just say I care about available tool for whatever reason, and I want this checked for whatever reason. There isn't a concern about isolation levels between available tool and checked out tool, and it won't be bypassed by using this check.
Well, it won't get pushed to master until that issue is addressed. So I suspect that what's going to happen is that we're going to get it working first for serializable isolation, just because it's a little bit easier to reason about it there. Serializable is the thing that has access to the predicate locks. And then figure out some other how. And I suspect the other hows for lower levels than serializable are going to be pretty aggressive about what they lock. Yes?
Yeah, so I'm just, maybe I'm kind of dumb here, but under the MVCC model, okay, so our query's going to get a snapshot view. So we've got this checked out tools table, and let's say that there's 5 tools checked out. We run our query, it kind of gets a lock on, well, not a lock, but it gets a fixed view. And part of that fixed view is those 5 entries that are in the checked out tools table. Well, during the time of that, a new tool gets checked out, I guess Insertion already doesn't know about it, doesn't really care about it. But it should. So I put forward, but I think actually it's designed to do this. Because we want to have maybe in the tools, available tools table, that aid on available thing is like, hey, here's what that's really an inventory. Maybe what we need there is a field that says these are the ones that are checked out, or these are the ones that remain available. So that's not really available, that's really inventory, right?
That's true. That should probably be inventory. I was talking, when I wrote down available tools, I was thinking which tools are available and how many of them. Not which tools are generally available, whether they're checked out or not.
Right, but you see, if you had that, if 8 is available is instead, a changing number to reflect how many are still available, then your query kind of has a view on that, and if you read the docs on, I think use a bank account example, deposit, that it would see if somebody else has updated that value. I think that would come into there would be visibility in our query. Oh, that 8 available is wrong. I think, right? Isn't that a classic bank account problem?
Yeah, it's like.
That's what the predicate lock use is trying to kind of address, to prevent those sort of issues. Go ahead.
Okay, so I think that's what using predicate locks is supposed to address, is that like if something goes in and violates it, no matter where it came in or when, it should still just bounce back out again. So the next, so like you're at 4, something goes to 5, you try to go to 6. At this point, you've hit the predicate lock, and and it should like bounce you. In serializable isolation, I don't think there's a lot of guarantees about just exactly which transaction gets rolled back. So it's sort of a coin flip between you and the other person that tried to do the right. I don't know if there's other systems where they have better serializable, but S2PL was just awful. It was serial 2-phase locking. And everybody implemented it and nobody ever turned it on, as far as I know. More questions?
We don't have a question. No.
More comments?
No, this is raises a lot of questions.
Okay. Well, alrighty. Well, yes.
I see the trivial version more efficient compared to when we have the insertion. The trivial only deal with an individual impacted role, but yours like the whole table, a table code bigger, and you scan all the index to get the count.
So the question is one about the efficiency versus of assertions versus triggers. I think I think that at the beginning, triggers will be more efficient just because they've been being worked on for decades. But they're not always is like the most efficient thing from the machine's point of view actually what you care about. Sometimes it's what can human beings debug more easily or look at more easily and understand. Because if you see one of those triggers, you don't know that there's another one somewhere. Like it's not, there's nothing that links those two things. Whereas if you see an assertion, you see all of what's being laid out rather than just kind of half of it that doesn't work all by itself. So, yes?
Just as a counter proposal, I'm not kind of arguing against the proposal. I just have a lot of questions. The implementation really leaves a lot of open questions. But just if you wanted to get to the more declarative all in one place, which I think is what you're prioritizing, could you just extend the create trigger by folding the function definition in? So you just say create trigger with implementation and the function code end.
So, so you say create
right
trigger.
Now, your complaint was we have the functions, the trigger function returns trigger, and by create trigger using the function, and you have to kind of chase stuff all around to see what's going on. So, and one of the advantages, this was the whole declarations in one place, which I agree is a good, I mean, that's nice, because the other pain. But could you just extend the trigger create to say create trigger with implementation begin, bunch code.
Okay, so yeah, so the question was, could we do something with create trigger with implementation? And I guess since our triggers are not at all what the standard mandates, we could probably do a thing like that. I'd still like to get assertions in there just because we'd be the first and
Also, it goes the wrong direction because now you have to attach a copy of that function to every single table. At least the current situation, you've got one function that you can attach to many
I'm not
tables.
saying we would eliminate the current situation.
Sure, but I don't think it helps is the point of it.
I'm just trying to address the question, the assertion that
I will-
getting it in one place was desirable.
I will also mention that deep code reviews of the implementation are probably best done on dash hackers rather than here.
It wasn't the implementation, it was the syntax.
well, the version that gets on dash hackers, I hope will be in this commit fest, and I will work hard to make it so. But Joe has asked, Joe Wildish, not this, okay, has asked me to. He said I could show it here, but he said please not to send it around because he wants to polish it a lot more than he got to polish it, and he did me a big favor by letting me have the current version of it. So, yes.
I've got just a general comment from the other people have a perspective on this, and that, I worked out in the industry for quite some time, but for Etsy for a long time. Generally, there's a lot of reticence amongst the people who think they know that business logic should not be in the database. So I can tell you right now, with an Etsy, it would be extremely hard sell to go say, we're going to go put some business logic into this insertion mechanism. It just kind of frowned upon. I'm wondering if everybody else, or how everybody else feels about it.
So the comment was about basically, there is a school of thought that says pull the business logic away from the database. And that is basically the AntiSchool of Postgres. In Postgres, you push the code to the data, and whatever code that is, it executes there. In like the you know, well, not even the SQLites, I guess the MySQLs of the world. The idea is that you push the data to the code. And so this is kind of a philosophical question and one that I won't resolve here because I can't. But philosophically, this goes very much with how Postgres operates, which is you push code to data because code tends to be very much smaller in size. And so there's sort of a fundamental efficiency there. That was the idea behind active databases. I don't know if you remember that particular spat, but.
No, I can't.
Okay, well, this was back in the early 80s, I guess. And the idea was that either databases were dumb data stores and you got basically just a minimal interface to do stuff with them, just enough to read and write. Or they were things that had their own CPUs in them and could do stuff for you. And it's that latter that the Postgres project comes from. So there was Ingress, that's in the early 70s, I want to say 73, 74. Post-Ingress project is 86. And then, and all through that, there's this sort of overlapping team of people that has taken on this philosophy that you shove the code towards the data. So I'm going to say at Etsy, this would not fly.
That's a common philosophy, keep the business logic out of the database. I worked other places where they hadn't even really thought about it. Like to solve a problem with a function.
That's why I put it out. I don't know what other people's experiences, because that's the line. And I love databases.
Sure.
I've worked places where I worried that the functions aren't even in version control and no one knows they're there.
Yeah. I was going to say tailing on what Joe just said, I'd say any plan is better than no plan. And no plan is fairly common in industry, unfortunately. Alrighty. Any more questions, comments? Yes?
Well, I like the idea that the assertion can preserve the states of the database, but I don't quite see how this can fly on each insert statement. Like this big group by statement, for example, the performance issue. So if that's possible to make it work like on a statement level rather than a row level,
So the comment was, it's not at all obvious how this would be implemented efficiently, and I agree with you. It's not obvious at all, and that's why nobody else has it. I'd like to have a much closer look at the code than I had time for, but I mean, I think a lot of the idea behind the second version, which is that you assume that the database is in a complying state, and that you check out what does the delta move you from a complying state to a non-complying state. So I'm guessing, like, for example, in the query, once it gets to the first tuple, it doesn't have to execute the query any further, right? So like exists will stop execution when it gets to the first tuple because it satisfied the query. It doesn't have to get the next tuple even if there's billions of them. Yes.
Well, that's actually a good point, though, because since this is an assertion about the state of the database as a whole and not about a specific table, it's not tied to a specific table like a trigger. What does that mean? Like every time there's a transaction, you have to run the assertion to make sure everything is okay? Or
Yeah. So
naturally, if there's some way around that.
Yeah. So this is another version of how the heck would you implement that, right? Like, I think the idea is that using the bootstrapping off of the predicate locking thing that Kevin and Dan put in, I think the idea is that there will eventually be a cheap way to check those things and like not check things that you didn't need to check in the first place.
I'm sorry to belabor the implementation, but I mean,
If you promise not to tell anybody, I will get you a copy.
So I have a client who has databases with 300,000 tables, and so it's going to have to filter pretty efficiently at query planning time and at execution time to avoid 45
Okay, so
minutes.
at the end of parse analysis, you have something that you can hand off to the planner that has identified the objects on which you're operating, right?
Including things in functions you might call.
Okay, so I'm gonna.
Or functions aren't permitted.
Sorry?
Or, prohibit function calls. I'm just looking for an answer.
Yeah, it might be necessary to prohibit function calls entirely inside of the constraints. But at let's see. When you call a function in your query, at what point does the database know that function is doing a write somewhere?
Doesn't have to be doing a write, because the assertion query is checking whether you have so many of something.
I think the question is, so does it have to run this assertion on every single insert into the database, unless some table, or does it have some way of knowing which tables are affected so it can reduce them?
I'm pretty sure it has a way to know what tables are affected, or we kind of have to.
I don't have your example up there anymore, but that covered how many tables?
Sorry?
It's how many tables are being checked. Could be any number. Not all of them are being written to.
So the thing I'm picturing is that there's something in the catalog that says which tables have assertions attached to them, and you would, as soon as you find the first one to which an assertion is attached in your write query, you should be able to, it should be a fairly short lookup. You're not like, the probe into this catalog, unless you've got like hundreds of thousands of assertions, is probably going to be short. You might even, I don't know, you could probably play some games with caching it.
Do you declare in the assertion syntax itself which tables are being covered by it, or does it figure that out from the syntax of the assertion?
It basically just figures it out from the...
Okay. Then there's the question of what happens if you write, if it calls a function that touches 23 tables that, although actually that doesn't, although actually no, that doesn't matter, because
Okay, so this, from like an assertion like this is all SQL, and what comes out of post-parse analysis is...
Right. I think the question is what happens if the assertion is where myfunc is true, and myfunc could do anything?
Yeah, well then halting problem, right?
Yeah. Right, and then, the question is what does, if the answer is do you say, well, don't do that, because it'll have to attach it to every single table?
Yeah, I noticed in the rest of the email, which I didn't paste in there, that he had, that for the second implementation, he'd torn out aggregates, and I assume it's for reasons sort of similar to that, is that he wanted to make it simpler, that he didn't have to go check.
So your implementation isn't part of that feature, your example?
Sorry?
Your example is not part of the feature?
It's not part of the second patch. The first patch it was.
Okay.
So the second patch is a complete re-implementation as far as I can tell.
So you should probably...
Oh, sorry.
We would love another talk on how it actually works.
Sure.
Let's do last questions, and then the person from Heap who came up to me. Why don't go up quickly before anyone asks any more questions.
about like why the problems we have with Postgres are like super interesting. So my name is Michael. I lead the database team here at Heap. And so to give you just a brief summary of what Heap does. So Heap is a user analytics tool where we will instrument our customers' websites and basically record all the events that people do on their website. So like someone clicks a button, someone signs in, and we record this information, and our customers can then analyze that information to ask questions about like how they can improve their website. And since we collect all this data up front, you can have pretty much any question, and Heap is guaranteed to have the data to answer. And so because we collect all this data, we actually use Postgres to store it. And we collect, so we have like a petabyte of data. And so we've had to sort of build our own distributed system on top of Postgres to handle all the scale and analyses that we want to support. We even had to build our own Postgres performance analytics tool in order to support, in order to figure out how to optimize our use case, where like none of the other tools we saw were really able to handle our needs. And so if this sounds interesting, come talk to me about it after.
Alrighty. Well, thanks everybody for coming, and thanks for your patience. Really appreciate it.
Thank you.